to my channel. My name is Prachi Sharma, and in today's session we are working on a much demanded video, that is mind mapping of organic chemistry. Our target is to make sure that you are able to revise more portion in less amount of time. So let's get started with today's session. So students, I hope my screen is clearly visible to you. So let's get started with today's session. Let me first explain you how today's mind map is going to work out like. So if you see, I have the first page. Now organic chemistry, we have a lot of portion on that. So I was not able to put it in 2 pages, but instead I have the map on 3 pages and a little bit portion after that. So technically 4 pages and your entire organic chemistry is revised in that much time. So let's get started with the first page. So I'll try to keep the video as short as possible. So let's get started very quickly, and if there's any portion that you don't understand or you are facing any doubts, make sure that you leave a comment in the comment box, or you can reach out to me on the Telegram channel, or you can also write me an email on tsclassesicsc@gmail.com. So let's get quickly started with today's session. Now, the first part of the session is the unique nature of carbon atoms. So, carbon atoms show two major properties which makes it unique compared to other elements. So, the first is tetravalency. So, what do we understand by tetravalency? So, it is a tendency of carbon atom to make 4 different bonds. That means to have tetravalency. Tetra means 4. Valency of 4 and an ability to make 4 covalent compounds or 4 covalent bonds is known as tetravalency of carbon atom. The second unique nature is catenation. Catenation is the ability of carbon atom to make long chains without breaking them. That means long carbon-carbon chain which is stable is catenation property. Now this chain can be formed in a straight format. It can be branched. That means you have few straight and then few branched up and down. It can also be single bond, or you can have double bonds in between, or you can also have triple bonds in between. So this is the entire property of catenation. Let's quickly read through it. Tetravalency, the characteristic of carbon atom by virtue of which it forms 4 covalent bonds, is called tetravalency of carbon. The second is catenation, the property of self-linking of atoms of an element through covalent bonds in order to form straight chains, branch chains, cyclic chains or different sizes is called catenation. Then in catenation, let's see, catenation, a formation of straight, branched and cyclic chains. So either you can have straight chains, they can branch out, or you can have a circular format, that is cyclic chains. The second is formation of single bond and triple bond. So, and also double bond is also possible. Single, double or triple bond. So single bond is this one, double bond is this one, triple bond is this. It can also have a triple or a double bond with a different element which is not carbon. Okay, so that is also possible. For example, double bond with oxygen and triple bond with nitrogen. Now let's move to the next part. This is hydrocarbons. When you have an organic compound which is made up of only hydrogen and carbon is known as hydrocarbon. These type of hydrocarbons can exist in a variety of types. So for example, the first is aliphatic, the other is cyclic. Aliphatic is everything you have in straight or branched. Cyclic is whatever you have which closes up. That means a circular chain. It can be of different types as well. So in aliphatic you get saturated and unsaturated. Saturated are the ones which you have single bonds of carbon-carbon only. Unsaturated are the ones you have double or triple bonds. In cyclic, you have alicyclic and aromatic. Okay, we'll come on that also. So let's first start with saturated and unsaturated. Another important thing is, in saturated you have alkanes. Alkanes means single carbon bonds. Unsaturated, you have alkenes and alkynes. Alkene means double bond carbon and alkynes means triple bond carbon. Okay, So let's get started with saturated and unsaturated. Now this difference is very important. Saturated and unsaturated. In saturated, we are talking about single bonds. Unsaturated, we are talking about double and triple bonds. So let's read it. All the four valencies of each carbon atom are satisfied by forming single covalent bonds with carbon with the hydrogen atoms. Okay. The second, the point over here, unsaturated organic compounds is the valencies of at least two carbon atoms are not fully satisfied by hydrogen atoms, therefore they self-link. Second point, carbon atoms are joined by single covalent bonds and carbon atoms are joined by double bonds or by triple covalent bonds. Let's move to the third point. They are less reactive due to the non-availability of electrons in the single covalent bond and therefore they undergo substitution reaction. Okay, so they are less reactive. Okay, that is because the carbon atom is satisfied in valency and is very stable in nature. Whereas when you talk about unsaturated hydrocarbons, so in that when you have a double bond or a triple bond and another element comes in to react with it, it can easily break that double bond to a single bond and can get attached to the carbon. So that is the reason they are more reactive in nature. They are more reactive due to the presence of electrons in the double or triple bond and therefore they undergo addition reaction. Addition reaction is an element comes in, breaks the double bond, attaches there with the carbon. Okay students, let's move ahead. Next we have homologous series. Okay, so first we'll understand what is homologous series. First you have alicyclic or cyclic ones. So let's come on here. So cyclic or closed or ring chain compounds, alicyclic. Alicyclic is any cyclic compound that you have, which can have 3 carbon atoms, 4 carbon atoms, and number of carbon atoms. That's alicyclic. Aromatic compounds are the ones which contains at least one benzene ring. What is a benzene ring? It is a cycle or it's a ring compound which has 6 carbon atoms and they get in this form. So double bond, triple bond, double bond, triple bond, single bond, double bond, single bond, double bond. Okay, so that's how your cycle gets completed. This particular compound is known as benzene. So if you look at this benzene here, so carbon, 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 carbon. So you have 6 carbons. So you have double bond, then you have a single bond, double bond again, single bond, double bond, and then single bond. So this is a benzene. So all the compounds which have at least one benzene ring is known as aromatic compounds. For example, toluene. So you have a benzene ring and then you have a CH3 on the top. So this is toluene, which is an aromatic compound. Aromatic compounds are known as aromatic because they have a very pleasant smell. Okay students, I hope that makes sense. Let's move to homologous series. What is a homologous series? So for example, we talked about alkanes. So alkanes entirely has a whole series. That means you have let's say methane, ethane, propane, butane. So alkanes have an entire series. Similarly, alkenes have an entire series, alkynes, alcohols. So all of these series are known as homologous series, which helps us understand what all is coming in one category. So let's understand the definition. A homologous series is a group of organic compounds having similar structure. Similar structure as in we're talking about alkanes, so all are single bonds. So when you see ethane written, so you'll know that whatever compound this is, it will have single carbon bonds. It won't have a double or a triple bond. Similarly, if we talk about an alcohol, let's say you're talking about methanol. So you'll know that there is an OH group attached in this compound because it's an alcohol. So homologous series helps us understand a group of organic compounds and help us distinguish between them. Because if you have alcohol, all alcohols will have similar properties. If you have alkanes, all alkanes will have similar properties. So it helps our understanding and our study of organic chemistry much easier. So let's look at the entire definition this time. A homologous series is a group of organic compounds having similar structure and similar chemical properties in which the successive compounds differ by CH group. So this is important for you to remember. Alkanes, alkenes, alkynes. Then you have some examples. For example, methane, ethane. Then in this case, you have ethene propene and ethyne propyne. Let's move ahead. Characteristics of homologous series. So the first characteristic is that all members share the same general formula. For example, you have alkanes, that would be CnH2n plus 2. You have alkenes, it would be CnH2n. If you have alkynes, it would be CnH2n minus 2. Each member differ by CH2 or 14 atomic mass unit. This is important for multiple choice questions. The next is physical properties change gradually. That means slowly physical properties change as you move along a homologous series, and they will have similar chemical properties. So physical properties, you're talking about melting point, boiling point. Chemical properties, you're talking about addition reactions, substitution reactions, any kind of reaction with a particular compound. All members of the series can be prepared by the same general method of preparation. That means if you're using the first, let's say if you're using propanol, so similarly you can use propanol for preparation of, let's say, a compound in the series. So similarly you can use adjacent compounds of the homologous series, and you can get adjacent outputs in the products. Okay, so when we do the preparation of alkanes or alkenes, you'll have better understanding of what I'm talking about. So let's move ahead to the homologous series of the significance of it. Why do we need it? So the first is the nature of any member of that family can be ascertained if the properties of the first few members of the series are known. So for example, if you understand the first few elements, that means you understand an entire series, and any element from that series can be easily identified when you talk about their chemical properties, physical properties, so you have better understanding of the compounds. The second is it helps to predict the properties of even those elements which are yet to be prepared. The third is knowledge of homologous series is useful for the systematic study of organic compounds. So you study organic compounds in a more systematic format. You know what is happening, how your compounds are behaving. So it makes it a lot easier. Alright students, let's move ahead to the next one. So in the next one, I have the first one as types of organic compounds. So organic compounds, in hydrocarbons, you have alkanes, alkenes, alkynes. That is carbon-carbon single bond, double bond, triple bond. You have alcohol, that is OH group. Then you have aldehyde, that is CHO. And then you have ketone, that is double bond O. So you have only till ketones. Alright, let's move ahead to the next one. Next is isomerism. Isomerism is then when you have the same given structural formula, say a given compound formula to you, but when you look at its structure, the structure can differ. So that is what isomerism is. Isomerism can be of two types. You have two types in syllabus, that is chain isomerism and position isomerism. So for example, if you know that a particular compound, let's say you have this one, so 1 2 3 4 5, so this is a pentane, all are single bonds. So for example, a formula is given to you for pentane, so that would be C5H12. Okay, so you have C5H12. So C5H12 can be written in a lot of formats. For example, all in a straight chain, or you can have one carbon not in the corner but attached somewhere in the middle, or you can have two carbons attached in the middle. So pentane can be written in these three different formats. So this is isomerism or isomers of pentane. Similarly, when we talk about position, so for in position, whatever functional group you have, for example, you have double bond, so it can be at different positions. So this is position isomerism. Let's move ahead. Next, I have alkanes. Okay, I'm starting with alkanes. So in alkanes, the formula is CnH2n plus 2. They are known as paraffins. That means less affinity or less reactive. They are pretty stable. So that means paraffins. Isomers of butane. So four carbons in straight chain, one carbon comes in the middle. So N-butane or isobutane. The other IUPAC naming would be 2-methyl propane. Okay, then isomers of pentane, so five are in straight, then one comes down, and then one goes up and one comes down. So this is n-pentane, isopentane and neopentane. These are the names. They can ask you for the formation of a structure. How would you make a neopentane? What is the structure of neopentane? So you need to know both the names. All right students, let's move ahead to the second one of alkanes. So how I have identified it as, I have written alkanes 1, alkanes 2. So it's easier for you to know what columns refer to which portion of the chapter. So let's quickly start with lab preparation of methane. So the reactants will be sodium ethanoate and soda lime. Why do we use soda lime and not sodium hydroxide? Because sodium hydroxide is deliquescent in nature. So we use soda lime, which is a combination of sodium hydroxide and calcium oxide. Let's look at the reaction. So CH3CONA plus NaOH gives you Ca in the presence of CaO, that is calcium oxide, at 300 degrees Celsius. It will give you Na2CO3 plus methane. Now, the collection is by downward displacement of water because it is slightly soluble in water and it is lighter than air. Let's move ahead to the next one. Now, this is your preparation diagram. So, you have a white granule looking structure right here. This is sodium acetate and soda lime, a boiling tube, and then you have methane being collected by downward displacement of water. Now let's move to the next one, lab preparation of ethane. So in ethane, now in the previous case you were using sodium ethanoate. In this case you will use sodium propanoate. When you are using propanoate, you get ethane. When you were using sodium ethanoate, you got methane. So this is how homologous series preparations would work. So the reactants are given. The reaction is C2H5CONA plus NaOH in the presence of calcium oxide at 300 degrees Celsius, giving us Na2CO3 plus C2H6. The collection is again by downward displacement of water, and the preparation, the diagram stays the same. It's just exactly the same as is. Instead of sodium acetate, you're using sodium propanoate. Let's move ahead. Other methods of preparation can be for example, from iodomethane or methyl iodide. So you have CH3I plus two nascent hydrogens, which gets combined with the CH3, and one of the hydrogens combined with the I that comes out. So what is happening in this reaction is, so you have, let me draw that. So you have CH3I. Oh, it's coming now. So you have CH3. So C, 3 H's and 1 iodine, and a nascent hydrogen will come in. One of the hydrogens will get combined with I and go out as Hi, and the other hydrogen will take a place over here. So this is how you get CH4 plus Ni. So same thing will happen with bromine. So you'll get C2H6 plus HBr. Let's move ahead to the chemical properties. Chemical properties, the first is combustion. When you have complete combustion happening, in that case you get a bluish non-sooty flame. The best example would be that when you have gas cylinders in the house and you have a flame burning under a big vessel and a good amount of oxygen is coming, you see a bright blue flame. So bluish non-sooty flame. Nothing happens to your container that you're making, let's say, boiling milk in. But let's say the gas is not getting, your burner is not getting sufficient oxygen. So in that case, what would happen is the entire vessel that you're using, it gets a blackish deposition on it. So this means not enough oxygen is coming in, therefore you're getting a sooty flame which gets deposited as a blackish color powder on the vessel that is kept on the burner. So that's the best example for you to understand. So when you have complete combustion, you get carbon dioxide, water and heat. When you have insufficient supply, you get carbon monoxide plus water. And when you have with very less oxygen, in that case you get carbon directly and water. And that carbon is pure soot that you get. And this soot is used for printing ink and tires. Let's move ahead to the next one. So this is your alkane substitution reaction. So substitution reaction, you use halogens. So the similar one that I told you for HBr. So what happens is one of the hydrogens will get replaced. So one of the hydrogen will get replaced. So this hydrogen will combine with one chlorine and you get HCl, and one chlorine takes the place of hydrogen. So substitution, it substitutes it. Then the reaction continues further. You get another chlorine attached and another one, and at the end you get CCl4 plus HCl. The names are written right here, that is dichloromethane, trichloromethane, tetrachloromethane. Now substitution products can be separated by fractional distillation. Why is that? Because you have a good difference in their boiling points, so you can easily differentiate between them or separate them by fractional distillation. So this is it for the second page. Let's move ahead to the last page. Not the last page, but the second last page. Let's quickly start with this. So we are talking about alkenes here. Alkenes is CnH2n. They are known as olefins. That means oil producing ones. Oil, like it's related to the formation of oils. Now isomers of butene. So you have one double bond, then that double bonds come into the center, and then one of the double bonds come toward the corner, and a carbon comes below here, right here. The different names would be but1ene, but2ene, and 2-methyl propene. Then ethene or ethylene, that is C2H4, is the first member of alkene series, occurs as a plant hormone, and is also responsible for ripening of fruits. It's important for you to remember. Let's move ahead. So similarly for the previous case alkanes, you have to remember that methane is a greenhouse gas. It is asked a lot in your multiple choice questions. Now let's come back to alkenes. La preparation of ethene or ethylene. The first part is dehydration of ethyl alcohol. Dehydration will happen in the presence of concentrated H2SO4 at 170 degrees Celsius. The reactants will be ethanol and concentrated sulfuric acid. The reaction will be C2H5OH. In the presence of concentrated H2SO4, it gives you C2H4 plus water. The collection will be by downward displacement of water. This is an inflammable, that is because it's an inflammable gas and insoluble in water. Now ethene is also prepared by this particular method. So in this case you have C2H5OH. In the presence of Al2O3 at 350 degrees Celsius, you get C2H4 plus water. Let's move ahead. Now in this case you have the preparation continues. So you have another method, that is dehydrohalogenation. So dehydrohalogenation means you already have a halogen connected to your organic compound. You bring alcoholic or a hot and concentrated KOH, that is potassium hydroxide, and you react with that. So what will happen is this KOH, the K will combine with your halogen and gives you KCl or KBr or Ki. So K, that is potassium, combines with halogens and gives you one output. The OH that you have, okay, the OH that you have will take out one hydrogen from here. So one hydrogen will go away from C2H5, combines with OH and gives you water. Whatever is left gives you the left out organic product, that is C2H4, and the same thing will happen for all halogens. So for example, you have Br, K combines with Br gives you KBr, OH combines with 1H gives you H2O, and you're left with C2H4. Now let's move to chemical properties. So the first is hydrogenation. Hydrogenation means the bond breaks. For example, you have double bond C and you're adding hydrogen. So what will happen is the double bond will break, it becomes a single bond, and the other hydrogens, like means two hydrogens, will get attached to it. So this is known as hydrogenation. So you get C2H6. This happens at 200 degrees Celsius in the presence of nickel. Let's move ahead to alkenes chemical properties. Second one, that is halogenation. In hydrogenation you were adding hydrogen. In halogenation you are adding chlorine. So if you, this is more clear to you. So one of the carbon bonds, double bond, will break. You get a single bond, and this left out valency is satisfied with a halogen, that is chlorine. The note here is that bromine solution in CCl4 has a reddish brown color. When added dropwise to ethene, the reddish brown color of bromine disappears due to the formation of colorless dibromoethane. This information is important for multiple choice questions. Let's move ahead to alkenes chemical properties. Third one, that is combustion. This burns with a sooty flame in air, and the equation is C2H4 plus 3O2 gives you 2CO2 plus 2H2O plus heat. In excess supply of air, it burns with a pale blue flame. Now let's move ahead to the next one, that is preparation. So flask should not contain air as ethyne forms. No, this is an ethyne one. So this is it. This is we are finished with alkenes. Let's move ahead and start with alkynes. So alkynes, first one is right here. Okay. Now students, another thing is that the nomenclature video is already there on the channel. So I'm not covering nomenclature in this particular session. We are just working on theory of organic chemistry. So let's start with alkynes. So alkynes, the formula is CnH2n minus 2. Isomers of butane is something like this. but 1 ion. So one of the three carbon at three bonds is at the corner, then it eventually comes in the center. So but 1 ion, but 2 ion. Isomers of pentine. So you have a pentine, you have the third carbon, right? Triple bond at the corner, then the triple bond comes towards here, and then one of the chains will break and one of the carbons will be attached somewhere in the center. So 3-methyl but 1 ion. Now ethyne or acetylene is C2H4. Then let's move ahead to the lab preparation of ethyne. The reactant, so water and calcium carbide, the reaction is CaC2 plus water, which gives you CaOH whole twice plus C2H2, that is your ethyne. Collection is by downward displacement of water. So by now, if you have understood alkanes, alkenes, alkynes, all three are collected by downward displacement of water. One common reason is that they are insoluble in water. So make sure that you remember that. Now, purification is important. This is important. A lot of students miss this out. Phosphine, hydrogen sulfide, ammonia, and arsine are formed along with ethyne. These are impurities. Okay. Why are they formed? Because your calcium carbide that you're using in the preparation, they contain some impurities, that is they are contaminated by what? By calcium sulfide, by calcium phosphide, by calcium in calcium carbide. So in calcium carbide you have two important impurities, that is calcium sulfide and calcium phosphide. Because of this you get phosphine, hydrogen sulfide, ammonia, and arsine as the important impurities which come out along with ethyne. So when we pass this ethyne through water, all impurities will get out. All impurity will get dissolved in water except phosphine. And to get rid of phosphine, what we do is we pass it through acidified copper sulfate solution or acidified potassium dichromate solution. So I can show you all of that is written right here. So on passing through water, all impurities except phosphine are absorbed. Then to get rid of phosphine, you pass it through acidified copper sulfate or acidified potassium dichromate solution. Let's move ahead. Then you have alkynes preparation. So flask should not contain air as ethyne forms explosive mixture with air. Then the second preparation is preparation from 1,2-dibromoethane or ethylene dibromide. So the formation is something like this. You have to, so again, this is basic understanding, okay? So you have two KOH. One of the K, so K will combine with your BRs. So you get 2 KBr. Then one of your OH will combine with one of the waters. So one of one H will come out. So you get 2H2O and two compounds to balance it out. Your equation, so I think this should be double bond. Yeah, I'm not able to write it somehow. Yeah, so this should be double bond. Then you easily end up adding to end up breaking that bond and it becomes triple bond. Okay, so that's it for your ethyne. Ethyne, the next part is the chemical properties. I was out of space there, so I have it written right here. So the first is oxidation, that means combustion. You burn ethyne. So when you burn ethyne, you easily get a sooty flame. So you get carbon dioxide, water, and heat, and this flame is sooty flame because you have more content of carbon here. Then you have catalytic hydrogenation. So that means in this case you are adding hydrogen in the presence of a catalyst, that is nickel. So the first stage would be that you add two hydrogens to it. Then in the second stage you add two more. So for example, you have alkynes, you're trying to reach alkane. Okay, so you reach alkene, then you add two more hydrogens, you reach alkane. So this is what is happening. Then addition of halogen. Halogen is what? Chlorine, bromine, iodine. So all, it is valid for all of them. So for chlorine, you have triple bond, you add up two chlorines, one of the bond breaks, you get ethene. So 1,2-dichloroethene. Then you add two more chlorines, you get 1,1,2,2 tetrachloroethane. Then acetylene reacts vigorously with chlorine gas in the presence of sunlight to give out flames, and the equation is given right here. So this was it for today's session, my dear students. I have tried my best to cover up the video, to keep the video as short as possible and give out more content and make your notes as crisp as possible. So This was it for today. If you want to download the notes, you can do that from the description box, or you can find it on the Telegram channel. Plus, you can also write me an email for any doubts and queries on psclassesicsc@gmail.com. Thank you for all the amazing support and love you're showing me on the channel. Please make sure that you share it with your friends and family and help me move forward. Thank you so much, and we'll catch up in the next session.